Hello everyone. Uh, in this video, I will just tell you what was the OA questions in my test, and many of you guys will be having your Texas placements now, so that's why I'm making this video. Okay, so this is the memory-based questions. So the values will be here and there. I have just assumed it by myself, but the pattern, the question was similar. Uh, uh, I remembered some of the aptitude questions and some of the technical questions. So I will give it here. Okay, so this was the first question. And uh, UV, XYZ are the six friends, and each one of them like one fruit from mango, apple, banana, pear, strawberry, and oranges. So there was some conditions like you like mango or banana, and for three friends it was given that uh, let's suppose apple is their favorite, strawberry is their favorite, and banana is their favorite, not banana, pear is their favorite, and some conditions were there. So from that you have to uh, tell what is the favorite of W. So this was one question. I will just quickly brief this because you might get the similar question, so you can practice that. In this video, my aim is to just tell you what are the difficulty levels and what are the topics that you have to study. Um, okay, so the next question was this: if sum of ABC, actually this was not sum of ABC. They have given the average of ABC. Average of ABC is 70, and if D is added, let me write it a bit clearly. Okay, so the average of ABC is 70, and if D is added in the group, what the average is 45, then what is the value of D? So that's how you can solve it. So similar way, you can assume it as X and 3, then you put X, put 120 and add D, then by 4. From this you can get easy questions, right? And then direction question was there first. 99 kilometers to east, 10 kilometers, then 10 kilometers, like this you can solve. 5 kilometers to left, then 11 kilometers to left, then what is the direction from the original, like what is the distance from the original. So this you have to calculate X. Then there was sitting arrangement questions. So uh, like some of the questions were very much similar, and some of the questions were a bit lengthy. It can take around 5 to 3 to 4 minutes easily. So this was a similar easy question. A was left to C, B is not the leftmost, and D is second left to D. So this is sorry, A D is second left to A. So this how D, and then you will get B. So this how some say like easy questions was there. So you just have to find the easy questions. And this was the easiest most question that I have seen in the interview. Like you can also see and check. Sushma is in middle, Reena is in left, so who is in right? So this how similar easy questions are. So you just have to find the questions, and some of the questions will be very much tough. See, similar to this was very lengthy. So I will just give you idea. He told that A is uh, 10 more than this, B is 20% more than C. This how this questions was there, and then they told if A has 10 coins, what will be the coin of G. So this will definitely take around 4 to 5 uh, minutes. And I just remember it now, there was also one question, it was of train, and that was a cat base that was cat question, and it will definitely take you around 6 to 7 minutes. Your like 6 to 7 minutes is very very lengthy, right? So 6 to 7 minutes in one question, you can't afford it. Okay, so next question was this. One rice like let assume at R1 rice is of 45 rupees per kg, and you have another rice that is 75 rupees per kg. Assume it has 7 R2, it is 75 rupees per kg, and if it is mixed together, and then the seller is selling it at 60 rupees, so what should be the ratio? So you can easily calculate this. You can assume it as x plus y, and then you can calculate, or there are many methods also. Okay, so the next question is, so this how the analog, like the aptitude was. There were other questions also. At this point I'm not remembering much. Okay, so just we'll go to the analog section. So this was the question. So by a simple node we can check, and whenever you get a diode question, just first assume it is in forward bias or reverse bias, and then check. If you are assuming that it is in forward bias, then the current should be, if this is the diode, then the current should be like this. If the current is opposite, then your assumption is false, and that diode will be reverse bias. So if here you will see, you have to apply the node. So V out by 10 plus V out minus 10 by 1 plus V out minus 10 by 1 is equal to 0. So from this you will get 3 V out is equal to 30, and therefore V out is equal to 10. So V out is equal to 10, so there is no current here. So we don't have to worry about this diode. So the assumption that we made that it is on is correct, because there is no current. If the reverse current is flowing, then we can say it is an reverse bias. So the answer that I have ticked was 10, and I hope it is this correct, and if I am wrong you can correct me in chats, but I think is this correct. And then this was a famous, nowadays these questions are getting very much famous. So you have this element which whose IV characteristics is this, and then what you have to do, you have to calculate the current across it, what will be the current in the circuit. So I don't remember the exact values of the graphs, but I can tell you how to do this. So what you can assume, think, if there is no resistance here, so what will be the current? The current will be uh, one, like the current will be 5, right? Okay, the current will be 5. So you just see, uh, the current will be 5, and let's assume this also be as 5, so the current will be 1. So if current will be 1, your current can't go beyond one current. It should be less than one current. If this characteristics has a positive resistance, and from this you can see it has a positive resistance. So this how you should check in which range it lies, and if you have defined the range, then you have to calculate the slope. So I'm just telling you the method. This is not the exact question that I got. So from that range you have to calculate the resistance of this, and then if the resistance is decided, then you can calculate the uh, current and voltage by this graph. Okay, so you can check, there are one or two gate questions of this type, so you can check that questions. And then this was a offset current question. So they have given, there is an offset current of I. Let's assume that I is equal to 10 nanoampere, and this is 0. This is in negative feedback. Let's assume that this resistance has 1k, and this has 1k, and then they have asked what will be the V out. Okay, so the current from here will be 1 by 5, that is 1 by 5 by 1 kilo, that is 5 milliampere. So 5 milliampere minus this offset will be traveling from this. So this node is 0, so 5 milli minus 10 nano ampere will be passing through this. So now into this resistance you will get the answer n minus. So this is how you can solve the offset current question. And this was most basic and easy question. They have given one PMOS, and then the drain side it is connected 1 kilo ohms resistor, and then like mu p cox was given, and WL was given, Wittgauge was given. So they have told you to calculate the current. So first assume that this transistor is in saturation region, and apply the formula of ID. ID is Kn dash WL VGS minus VTH ka whole square. This you can apply, and by this you check if this is in saturation region or not by the condition. So what is the condition in PMOS? There are many ways from which you can remember the region of operation. What I do is, I will cover in some other video, but I will just tell you. I just check if this condition is true, then it is in linear region, and if this is VTH, and if this is true, this is in saturation region. In some other video I will just explain why this two equation makes sense. Then, like, rather than remembering the big formula of VDS and VGS, not knowing what happening in the equation, you can remember this. And someday I will make. So this was in saturation region, so I have calculated the current. So, and it was NAT question. NAT means you have to type the answer. There were no options. So this was NAT, and prepare for NAT also. And this was the BGT question. So we'll not go into the exact solution of this question because this is very basic. So this is the voltage divider circuit. Okay, this is the voltage divider circuit. Let us assume it has 1 and 5. So we will have this voltage as 1 by 6 VDD, and then you can apply this loop. This will be 0.7. Then so VDD by 6 into 5 minus 0.7 will be the voltage across this resistor. So you can calculate the current as well as the VC, as this current will be approximately same. So in the questions you don't have to add the base current, that will be approximately same, and if it is MCQ you can eliminate the options and check. So the tip is, consider IC is equal to I, don't add the base current also. Okay, so this was the question, and there were one question on 555 timer. I haven't revised this, so at the time of test I wasn't able to answer this question, so I left it. So you have to be very sure which questions you have to left and which questions you have to attempt. Some of the questions will be very easy, and some of the questions you might be knowing, like it might be difficult, but still if you have confidence on that question, you will attempt it. Okay, and don't attach your feelings to some questions. If it is hard, leave it. Don't take it on your ego. And now, yes, this is the question that has been asked in many of the interviews, and I will just give you the brief. So whenever you are having a question on ADCs, then you must take care if V reference is given or if V full scale is given, because whenever you have a full scale, then V full in this question V full scale is 1.8. That means the full scale of the digital value, once it is reached, like when you give 1.8 volt, the full scale value of the full scale digital value will be given by the ADC. Okay, so if I give 1.8 volt, the full scale value will be given, digital value. So what is the digital value of 4-bit ADC, it has 1 1 1. Okay, so uh, to generalize this, what we can write? We can write 2 raised to power minus n. Okay, so what is this? 2 raised to this is 1 2 4 8. So what is this? This is 15. Okay, so this is how you can see. So if 1.8 goes to 1.8 gives 15 in digital, so what 1.5 will give? So by this simple multiplication you can calculate. So 1.5 into 15 by 18. Okay. Okay, so from this we can derive the famous formula, that is V out is equal to 1.5, that is V in into the 2 raised to n minus 1, 2 raised to n minus 1 divided by your full scale. So you can write it here. Okay, so whenever you have full scale, then it is related to 2 raised to n minus 1. Okay, and in the V reference is not actually achievable. That means if you give the input as V reference, then the bit will be overflown. So to make the sentence more understandable, we have D out is equal to V in into 2 raised to n divided by V reference. So this remembering 2 raised to n is much simpler. That's why to have an direct relation from 2 raised to n, we have a V reference to make the calculation simple. Because we remember like 2 raised to 4, right? Like 1024. So calculating 1024 is simpler. Calculating 1 to 5. Sorry, this is correct now. Yes, this is simpler than this now. That's why for the simpler calculation we use V reference in your practical life. Okay, so I think now, and then this was also one more question where they asked to calculate the characteristic equation when Vn is natural frequency is given and damping factor is given. So you know the characteristics equation is this, right? So directly calculate. And then they also told to calculate the transfer function when the DC value is given. So this is DC value into bandwidth. So bandwidth means, and this was the first order circuit, so tau is 1 by bandwidth. So from this you can get the tau, and then there were no zeros, so this divided by 1 by s. Okay, so this you can do, not 1 by s, this should be 1 by s by p, because if s is equal to 0 you will get DC value. This is DC. Okay, so this is how you have to represent your transfer function. And the next question is similar. They just want you to have a transfer. This is also about the transfer function. So many people will just directly do the calculation. They will apply Laplace. They will do, but if you are smart enough, you will calculate with these things. You can calculate the DC value, you can calculate the poles and zero, and you can directly calculate the transfer function. So how to calculate the poles and zero in this? I think you will be familiarized. So as this, so this C1 and this was not equal. So if this is not equal, there will be zero in it. So when zero will be there, when this will be, this impedance will be zero, and as this is not equal to this, so this will be some finite resistance, like impedance, finite impedance, and this is zero. So you will get zero when this impedance goes to zero, and you will get pole if Z1 is equal to minus Z2. So this is Z1 and this is Z2. So this is how you have to calculate the poles in zero and calculate the transfer function. And the DC, so what will be the DC value? at DC, what will happen? Both the capacitors will be open circuited, right? Open circuited, and you will have 1 by 2 as as you will have as you will have this circuit. So if R1 and R is same, then you will get it. Like you will get half, or you will get R divided by R1 plus R. So this was the question. I hope the pattern is clear. So most of the questions are easy but yet conceptual, and some of the questions are really scoring. So find that questions and score as many as you can, and then go to the conceptual questions. Okay, thank you.